Hello viewers and welcome to this series on testing of bricks. Bricks often have to withstand great compressive stresses. The durability of a masonry structure largely depends on the strength of bricks. As per IS 1077/1992, the common building bricks should have a minimum strength of 35 Newton per millimeter square. Also, the compressive strength of any individual brick should not fall below the average compressive strength specified for the corresponding class by more than 20%. In this program, we shall see as how we determine the compressive strength of bricks. The apparatus consists of compression testing machine of capacity of minimum 100 ton or 1000 kilonewton and with 1 ton or 10 kilonewton accuracy. The compression plate of the machine should have a ball sitting in form of portion of a sphere, the center of which shall coincide with the center of the plate. 3 ply 3 mm plywood sheets are also used. Cement, clean coarse sand is required and we need mixing tools and enamel tray. Select 5 whole bricks from the samples as specimen for this test. Immerse this specimen in water bath for 24 hours, maintaining a temperature between 25 degree to 29 degree centigrade. Take out the bricks after 24 hours. Allow any surplus moisture to drain out at room temperature. Now, prepare mortar of the ratio 1:3 using clean coarse sand of grade 3 mm. This mortar shall be used to fill the frog of the brick. Fill the frog of the brick flush with mortar. In the same manner, we shall fill all the 5 bricks. This is done to bring the brick to a uniform section. Keep the specimen under damp jute bags for 24 hours. After that, we shall immerse the specimen in clean water for 3 days. Wipe out the brick of any traces of moisture. Measure length and width of each specimen correct up to 1 mm. The length and breadth of given sample of bricks are 22.05 and 10.05 for sample 1, 23.0 and 11.0 for specimen 2 and 3, 22.05 and 11.0 for specimen 4, and 22.04 and 11.01 for specimen 5. Place a 3-ply plywood sheet of 3 mm thickness on the base of machine. Place one brick specimen with flat face horizontal and mortar filled face upward. Place another 3-ply plywood sheet carefully. Center these between plates of testing machine. Now, apply the load carefully and axially at a uniform rate of 14 Newton per millimeter square per minute. Observe the reading when the failure of specimen occurs. Now remove the crushed specimen, and in the same manner we will test all the other 4 specimens. The compressive strength of each specimen is calculated in Newton per millimeter square using this formula: maximum load at failure divided by area of specimen in millimeter square record the observations. The compressive strength of each specimen is calculated in Newton per millimeter square by dividing the maximum load at failure by area of specimen. In case the compressive strength of any individual specimen is found to exceed by more than 20% of the recommended value, we shall limit this value to 120% of the specified limit. That is, here we have used the class designation 10 bricks. So, if any brick indicates a crushing value by more than 12 Newton per millimeter square, we would have restricted the compressive strength to this value. For the brick lot we have tested, we have found that the average crushing strength is 10.7 Newton per millimeter square. A brick lot is considered to have satisfied the requirement of compressive strength if the average compressive strength of the 5 specimen is equal to or more than the specified value as per the table, and also the crushing strength of any individual brick is not less than by more than 20% of this value. For this lot we can conclude that this satisfies the requirements of Indian standard. Similarly, we can conduct other tests on this specimen and find as whether the bricks are good for use in construction. Thank you and goodbye.